Hey everyone, I'm back. And so we are doing the nervous system right now, and we are talking a little bit more about some of the finer points of the action potential. And right now we're also looking at excitatory postsynaptic potentials, EPSPs, and inhibitory postsynaptic potentials, IPSPs. And the next thing I kind of wanted to just like touch on is this idea of spatial and temporal summation, right? Summation, just to means this, like, 1 plus 1 equals 2. It's a sum. It means you add some stuff together and then you get a bigger thing, right? And so that happens also with these tiny little graded potentials, right? And we're just going to look at how that happens. All right, summation stuff. So let's review firstly. So let's start with just a quick review. So here's excitatory postsynaptic potentials, the EPSP group, right? And so with these types of graded potentials, and the reason we call them graded potentials is because we kind of have to like use more than one, right? We have to get a gradient going, like multiples. Anyway, so right down here is what we our resting potential of our membranes, -70. And as you know, an excitatory postsynaptic potential doesn't mean that we're actually going to get an action potential just because we get a stimulus. It's too small, right? It doesn't reach like this very important place, and that place is a threshold, right? So for us to be able to reach threshold, so we can actually pop over and get that action potential, we need to have multiple excitatory postsynaptic potentials. But what it does do is it like brings us to like right here. So it's like a feather touch. Like we don't need much, but even if we get like the littlest nudge, we can, boom, jump into a full-blown action potential and transmit that signal down the axon. So excitatory postsynaptic potentials again. So what they're doing is they're just kind of getting us ready so that we are, we can fire off our signal right away once we get enough stimulus. Okay. Conversely is the inhibitory postsynaptic potential, the IPSP. Again, so it's a type of graded potential. So it does this thing where it tells cells, instead of like, get excited, like for excitatory, like, oh, what's going to happen? It's just, it's just get ready. What it does is it says, hold off, hold off. There's signals in the area. It's not for us. It hyperpolarizes it, right? It makes it, much lower. So like somewhere in the ballpark of like negative, like maybe 90 millivolts, for example, or even 100. So it makes it so the cell really is suppressing its ability to get action potential. So it would have to take a lot of other stimuli just to get us back up to threshold. Okay, so it just kind of really shuts it down. So that's that type of graded potential. And so this idea now of summation kind of comes into the mix. So you can see here, if we have a really low, this threshold has brought us low. It's brought us, close to like 90, for example. Then we're going to need like a couple, at least. We're going to have to summate, right? Like, remember we did this like 1 plus 1 equals 2. Well, in this case, like one excitatory postsynaptic potential plus another excitatory, how should that become there it is, becomes like an actual action potential. Okay, so we have to sum them. We have to have multiples of them in order to pop into an actual stimulated state. Okay, let's look at some ways we can do that. Let's look at how that occurs. Okay, so and this is kind of this is a temporal, right? So when we're talking about temporal, we talk about time, right? And so in this case, you might have like, here's this neighbor neuron over here, right? And here's that axon. And so what it's done is it sent two signals, right, that correlate to like these two signals right here, right? And it just sent them close enough together in order for us to, go ahead and reach a threshold and have an action potential. Okay, so that's temporal. They just, hey, get ready. And then it said right away again, hey, get ready. And that was enough. Boop, action potential. But there's another way to do it. So let's say here's that same neighbor. right? And it sends that same action potential, or not action potential, it sends that same excitatory postsynaptic potential, just that little bit in the area. And so it says, okay, hey, get ready. And then like you don't hear from it for like 2 or 3 more weeks, or for a really long time. And then all of a sudden you're like, oh, I guess nothing's going to happen. Oh, I'll just go back down here to resting. Well, it's kind of a little further than resting. Sorry. Resting. And then all of a sudden, like, he's like, oh, wait, hey, it's going to happen. And then you're like, okay, great. I'm ready. I'm almost at the threshold. I'm ready. Nothing happened. Okay, no. There's too much time was the issue that like lapsed, right? So that's the issue. And so that's how you don't get summation there. Oh, I kind of crossed it out. Oh, that didn't help at all. Okay, that's how you don't get summation, right? So that's why it's timely, right? We need it timely for those. That's not the only way we can get summation though. So here's another way, all right? So in this case, our neighbor last time just sent that one, right? And then it took a while and then sent another. But here's an idea. Like in some cases, you'll have these neural networks and they're hooked up and they'll, send signals like, if not right at the same time, like really close enough to each other, right? So here's like the first one, the E1, and then here's like, oh, here's that excitatory 2 right here. And boom, we've reached threshold and pop action potential, okay? So this is different because it's not about timing. It's about space, right? Spatial, okay? So for this one, it's because there's like just enough happening in a space, okay? So they're close enough together that they can both activate this neuron here, right? There it is. And so the action potential is achieved. So there's space and there's time, right? So neighborhood. Okay. So here's another one that's kind of interesting. All right, here's our excitatory one. Hey, it's gonna happen anytime. It's gonna happen, right? So here's E1. But then the neighbor does this one. So then you have this other neighbor this time, and this other neighbor's like, you know what? I don't know, man. Maybe not, actually. Maybe just, no. Maybe we're going to inhibit. Maybe just shut it down, right? And so here's this inhibitory signal, and that makes it, so we have to have a resting memory potential that's lower, right? So maybe it's somewhere around that 90 range, maybe 100 range. So when we have our excitatory signal that comes in, it's like, it's only really just lifting us out of there. It's not really bringing us that distance that we need to reach up to threshold, right? So that's another one. That's how an inhibitory works, is it kind of competes, right? It brings it down a little bit more. And so this is technically also like a spatial, right? Because we're looking at, a couple of them in the proximity. Okay. So I hope that was helpful. I just kind of like to go over some of these like finer points individually, because I find that it's just a little bit, needs a little bit of clarification. Okay, so if you need anything, please feel free to reach out to me and come see me during office hours, and have a lovely day.